Hi all. So today we will talk about problem 4.5, walking east on a turntable. It's about this turntable that is rotating clockwise at constant frequency omega, and a person walks on it towards the east with constant speed v. So let's try to first visualize what is going on. So let me draw a bigger version here. So imagine this is the turntable and then the center is here. And let's say the person is, let's say here. What are the speeds or velocities? So we know is the person's always walking eastwards with speed v, and then we also know that the turntable is rotating at constant frequency omega. So then there must be some sort of component, some sort of velocity pointing this way, and let's call that u. And then let's represent the position of the person right now as a vector called r. And let's call this theta. We want this theta because we want to separate this motion into some sort of directions. We want to decompose this direction. So let's try to decompose this into x direction and y direction. So x direction is this way and y direction is that way. So let's try to do that. So for the x direction, let's call the speed x dot, representing dx dt. So what is this equal to? Well, we know it has a constant speed v, right? Because the person's always walking eastward with constant speed v. So v is definitely here. And what about this velocity here, u? So if this is r, this is theta, and then you have u here. And we know that this must be perpendicular because this is the position vector and this is the tangential velocity of the turntable of the tangential the tangential velocity of the turntable. So how can we decompose this? Let's see. Let's try to decompose this again into x and y directions. So this triangle here with this as the right angle. So it will look like this. So this is u, this will be the triangle. And we know that this is theta. So look at this triangle here. This is 90 degrees. This is 90 minus theta. So then we know that this is 90, and so this must be theta too. This must be theta. So this is theta. So just to be clear, let me draw again. So this is r, this is u. We know that this is always a right angle, and we know that this is theta. So this angle here is theta. And then let's create a triangle here. So this is a right angle. And so this is 180 minus 90 minus theta. So it will just be 90 minus theta. And this is 90 degrees. And then let's decompose u into this. And we know that this is a straight line. So this angle here must be 180 degrees. And so if this is 90 minus theta, this angle here, this is 90, this must be theta. And so we know, that's why we know this is theta. So now let's try to decompose u. So we would do v minus u, the x component of u, and that is u sine theta. So this is the component, this is the x direction velocity, which is v minus u sine theta. And for the y direction, y dot representing dy dt, v doesn't contribute because we know the person always moves eastward and there's no y component therefore. And so we decompose u. So it would just be u cosine theta. And so now we have the expressions for the velocity in the x direction and the velocity in the y direction. And next, let's see what we can do with these. So what do we know about u? So u must be related to omega somehow, right? So omega is a constant frequency, but we can also see it as the angular speed, the so how much the turntable has turned. So we can see it this way. So then u is the velocity, the tangential velocity, and omega is the angular velocity. And how do we relate these two? Well, we can relate them by the formula u equals to omega r. This is the relation between angular velocity and the uh, translational velocity. And so now let's rewrite these expressions. So x dot becomes v minus omega r sine theta, and y dot equals to omega r cosine theta. And now let's see, can we simplify a bit more? So remember that we define r as the position vector of the person and theta as the angle. So doesn't this look familiar? This is basically a polar coordinate system that we're constructing. So if this is r, this is theta, what's the x and y coordinate of this point? Of this point here? Well, it's just r sine theta and y cosine theta. X is just r sine theta and y is just r cosine theta, right? So see, we have y here and we have x here. So we can again rewrite this. So x dot equals to v minus omega x. Y dot equals to, oh sorry, x. So here, x is cosine theta, r cosine theta. Because this is r, this is theta. So adjacent or hypotenuse, x is r cosine theta, and y is just r sine theta. And so now x dot is v minus omega y, and then y dot is just omega x. And so now we have these. So what can we do next? Well, somehow we need to solve, this system is definitely solvable because we have two unknowns. It might look like 4, but then we also have the formula x dot equals to dx dt and y dot equals to dy dt. So we're really just solving for two variables here. And we have two equations, so this must be solvable. So let's see if we can substitute something. So do you see the y here? And we see the y dot here. So it would be nice if we can do some sort of manipulation and just substitute y dot into this formula. So why don't we just differentiate this formula, this equation here? So it would be d dt x dot equals to d dt v minus omega y, and this just becomes x2 dot, so representing the second derivative. And since v is constant, it becomes 0, and omega y, after you find its derivative, it's basically minus omega y dot. And so this is the formula now. And now we can substitute y dot equals to omega x back into here. So now we get, so we know that y dot equals to omega x, and you have y dot here. So then x2 dot just equals to negative omega squared x. And this is rather familiar. This is the differential equation for oscillatory motion. And we can just solve for it straight away. But let's go step by step. Let's first observe this equation. So something's derivative, second derivative, is still something, but times a constant. So what kind of functions yield that? So we know maybe sine, because sine derivative gives us cosine, and cosine brings us back to negative sine. So that's an option, and same thing with cosine. Or maybe an exponential. An exponential always gives us exponential after the derivative. So let's actually go with the exponential because we know that these three are actually related because we know e I theta equals to cosine theta plus I sine theta. So let's go with e first. So let's guess a solution. Let's say let x be e alpha t. And recall that like the original formula was x2 dot equals to omega squared x. So then this becomes alpha squared e alpha t equals to omega squared e alpha t. This because we know this is just alpha e alpha t, and then x2 dot is just alpha squared e alpha t. And so it's actually negative omega squared x here, so it's negative. And then we can move this to the left side, and we have alpha squared e alpha t plus omega squared e alpha t equals to 0, and we can cancel out the e alpha t. And so now we have alpha squared equals to omega squared. Move it to the right side, we have this, and so alpha is equals to square root negative omega squared. And now we need to use complex numbers here. So alpha just equal to I omega plus minus. So now we've gotten two solutions for alpha. And next to find, we found two roots. And next to find the general solution, we need to combine these two. So we assume x to be e alpha t, and so now x is just e plus minus I omega t. And from here we have two roots, and so to construct a general solution, we need to combine these two. So, and also they're a linear combination. So x of t would be a e I omega t plus b e negative I omega t. And so this is the general solution. And how can we write this? Well, recall that e to the power of I theta equals to cosine theta plus I sine theta. So again, we can rewrite this. So x of t just becomes a cosine omega t plus I sine omega t plus b cosine omega t minus I sine omega t. And we can combine signs, so that term and this term can combine. So we have cosine omega t and then a plus b plus this term and this term. So we have I sine omega t, a plus b. And then next we can solve, we've gotten the general solution. So this should be a minus b here. So because the term here is negative bi sine omega t. So now we just give two different constants. So let's call this c. So c cosine omega t, and we call this and this. So let d be a minus bi. So this becomes d sine omega t. This is the general solution. And since we're solving a physics problem, we only look at the real part, this part. So we can just write it as x of t equals to c cosine omega t plus phi. So phi is basically so phi and c are both determined by the initial conditions, and they need to be specified. So phi is basically where this particle is starting. And so now we've gotten the solution for x of t. And now remember that originally we had the equations x dot equals to v minus omega y dot equals to omega x. So then now we have x, we can also get y. So it would be easier to just go to this equation, because this one we also have to integrate afterwards. So it will be, so we know x of t is c cosine omega t plus phi. So x dot t must be omega c cosine negative omega c sine omega t plus phi. And so now we know negative omega c sine omega t plus phi must equal to v minus omega y. And so what is y? Y, let's move this to this side and this one to that side. So omega y equals to v minus omega c sine omega t plus phi. And so now y equals to, this is actually v plus omega c sine omega t plus phi. And so now y becomes omega c sine omega t plus phi plus v over omega. And so now our solutions are x dot y. So the coordinate is c cosine omega t plus phi, comma c sine omega t plus phi plus v over omega. And so this is our solution. And remember I said we need to find these based on the initial conditions. So let's try to do that. How can we do that? Well, let's see what happens if we set what happens when time equals to 0. So this is the initial condition at 0. So at t equals to 0, we have x dot y to be, so if this is 0, we don't have this term, so it'll just be c cosine phi, comma c sine phi, plus v over omega. And so how can we, and so we know that at t equals to 0, x is x naught and y is y naught. So these will be constant. So let's say, because the question didn't give us some initial conditions, we just assume x naught and y naught are the initial coordinates of this person. So then now we know that c cosine phi must equal to x naught, and then c sine phi plus v over omega must be y naught. And then what can we do? Well, let's try to find c first, actually, because we can utilize the identity sine squared theta plus cosine squared theta equals to 1. And so how can we do that? So let's rearrange this first. So c sine phi is just y naught minus v over omega. So then let's square both equations and add them. So we have c squared cosine squared phi plus c squared sine squared phi equals to x naught squared plus y naught minus v over omega whole thing squared. And so now we can group these terms. Now we know that this one just becomes 1, so we have just c squared equals to x naught squared plus y naught minus v over omega whole thing squared. So then c is square root x naught squared plus y naught minus v over omega whole thing squared. And so this is c, the constant. And then now we can try to find phi. So again, we see sine and cosine. What can we do? Well, why don't we divide these two equations? Actually, why don't we divide these two equations? So we had c sine phi equals to y naught minus v over omega, and c cosine phi equals to x naught. And if we divide these two equations, we get tangent phi equals to y naught minus v over omega over x naught. And so we can just get phi by taking the inverse tangent. And so our final solution is x comma y is c cosine omega t plus phi comma c sine omega t plus phi plus v over omega, where c equals to square root x squared plus y minus v over omega whole thing squared, and phi equals to inverse tangent of y naught minus v over omega whole thing over x naught. And so that is our solution to this problem. Thank you for watching.